Hello, and welcome to 7.5 Altitude on Hypotenuse Theorems. We're still working with similarity, but specifically we're going to be working with right triangles. So the first thing we actually need to know is what geometric mean is. Now, arithmetic mean is like the average. If I ask you what's the arithmetic mean between two test scores, you get like, let's say a 90 and a 100, you just take 90 and 100, add them up, and divide by 2, okay? Geometric mean is slightly different. It means if I were to take the geometric mean of, let's say, 8 and 6, we would actually write a proportion. X over 8 is equal to 6 over x. And that's how we would work with the geometric mean. We would cross multiply, solve for x, so we get x squared is equal to 48. Square root both sides. And then once you simplify the radical, x would be equal to plus or minus 4 root 3. Okay, so that's a geometric mean. Now, how does that apply here? Well, in a right triangle, if we created an altitude, and if you remember the definition of altitude, awesome. It means we go from the vertex to the opposite side, base, and create a right angle. So we would have a right angle on the very, very bottom, actually 2 of them. We would actually have a whole bunch of similar triangles. If you don't believe me, let's, for instance, and I'll do this in pink so you don't have to copy this, 30 degrees at this A. Oh, we also create a new point here, D, and we have 30 degrees for CAD. Now, we already have 90 degrees here, which means angle C is 60 degrees. But something interesting happens here. Because of that 90 being split with the 30, the complement to 90 and complement to 30 is 60 degrees. And then we have a triangle here, ADB, which has 60 degrees and 90 degrees, which means angle B in the corner has to be 30 degrees. Last but not least, we have, well, first we have 2 triangles that are similar because the left triangle and the right triangle have the same angle measures by angle. But if you look even closer, this big triangle that we just have has an angle of 60 degrees and 30 degrees as well. And ironically enough, 90 degrees. So we actually have another 30, 60, 90 triangle. So I'm going to break this up and highlight. I'm going to do, let's start with blue. I'm going to make this first triangle, and let's make this a little thicker. Blue triangle. We'll have a green one on the right. And then last but not least, we'll do a red one for the big triangle. Just going to kind of outline this so we could see this a little bit better. Now, let's draw these triangles separately just to kind of help illustrate this. Start with the big triangle, right angle here, and then let's name these parts. So we have C here, we have A here, and we have B here. Oh, even before that, let's actually name the parts of the red triangle, the big triangle that's drawn to the left. This whole length here is directly across the right angle, which means it is the hypotenuse. Hopefully you remember that. I'm going to put hype for short. Anything that's not a hypotenuse is a leg, so I'm going to call this leg 1, AC, and then AB would be leg 2. So that's the red triangle, L1, L2, and then the hypotenuse. Okay? Then we have the blue triangle. So let's draw this separately. Blue triangles on the left side of it, and we're gonna label this based off of the parts of the red. Now, if you notice, the blue part has a little sliver of the hypotenuse. It's not the whole hypotenuse, so we're actually gonna call that part 1 because it's only part of the hypotenuse. And then we're gonna call this the altitude, as we already discussed, because it goes from the vertex down to the base. So we're gonna call this the altitude. And then now we can properly label this triangle. We know this side is L1. Even though it's a hypotenuse on this small side, it's technically L1 according to the red triangle. We have a right angle here. We have the altitude, and then we have part 1. So all of this is being labeled according to our giant triangle. Now let's do the green. Green triangle as so. And we could label all of these parts accordingly as well. The giant side is L2. The hypotenuse according to this anyway. We only have part of this hypotenuse, so we're going to call this part 2. And notice L1 matches up with part 1, leg 2 matches up with part 2. So we're going to call this part 2, and then this again is the altitude. All right, so as we mentioned, the corresponding parts follow, okay? For instance, this is 60, this is 30, but then here in the blue triangle, this is 60, this top part is 30. And then for the green, we have 60 here and 30 here, okay? We need to realize that some of these parts actually line up with each other, and they're all corresponding. They all are similar. So we actually could organize this information a little bit better. So let's do this. Red triangle we know is similar to the green triangle, or blue, let's go blue first, is similar to the blue triangle. So let's compare these particular parts. If you notice, they both have L1 involved. So we're going to actually use this because that's part of our lesson with the geometric mean. They're using the same values and multiplying them against each other. Okay, so here we're going to create an equation, leg 1, and then we're going to write a proportion, an L1, so that we get that geometric mean. The question is, what are the parts that are corresponding that need to be multiplied with each other? And we take a look. Well, if you look at the overlapping pieces, part 1 and the hypotenuse both have red and blue involved. So we're going to compare those parts accordingly. From left to right, we're going red to blue. So this part, whole part, is the hypotenuse. So we're going to put a hypotenuse in the denominator here. For the blue triangle, the overlapping part is just part 1. And from here, we could create an equation. Once you cross multiply, we're going to L1 times L1, L1 squared, leg 1 squared, is equal to part 1 times the hypotenuse. And this is our first equation, okay? Our second equation, we're going to go red to green this time. So let's go red. The red triangle is similar to the green triangle. Now let's look for some overlapping parts. We're going to write a proportion, and then they both have L2 in common. So we're going to put L2 in opposite corners. And then we're going to look for another pair of overlapping parts. We see that we do have it on this hypotenuse. So from red to green, we're going to talk about the hypotenuse, the whole length of the hypotenuse, which overlaps with part 2, P2. And when you cross multiply here, leg 2, multiply with leg 2 is leg 2 squared, multiplied with part 2 times the hypotenuse. Very convenient. L1 is with part 1 times hypotenuse. Leg 2 is equal to part 2 times the hypotenuse. Very, very convenient how this equations turn out. The last one is this, green compared to blue. They are similar. So we're going to go blue to green because that's from left to right. It makes it a little easier to follow. The blue triangle is, in fact, similar to the green one. So we're going to do this. If you notice, they both have the altitude in common. Okay? And in this particular case, we actually need to do a little bit more digging. For the sake of it, you could just follow all the way to the very end. I could just give you the equation to follow it, but it'll make sense when we actually cover it. Altitude. The altitude is the commonality here, so that is going to be our geometric mean, altitude. Okay? Now this is the part that's a little strange. How do you know which ones to compare? Because there's no real overlapping parts here. Well, looking closely, part 1 is between, altitude is actually the, here, let's do it over here, actually. It's a little better to understand. The altitude and the blue triangle is actually attached to the 30-degree side, okay? Which means it corresponds to P2. That is very important to understand because here the altitude is attached to the 60-degree side, and that is corresponding to part 1. So we need to correspond these properly. Since we're going blue to green, altitude in the blue over part 1 is equal to part 2 in the green over the altitude. And here, we could create an equation. Altitude times altitude, altitude squared. Part 1 times part 2, just stays that. And then we have our third equation. So here we need to know these three equations if and when we have an altitude on the hypotenuse. If we have this occurring in a right triangle, specifically a right triangle, then we could use one of these three equations to start solving for those specific pieces. Okay? So, this is our lesson for the day. We'll get a ton of practice with this, and if you have any questions, please let me know, and I'll see you in the next one. Bye.